Hello friends, here in this video we will see a problem on calculation of moment of inertia for a given section. And here we have a question. Calculate moment of inertia about x-axis and y-y axis for the section shown in figure below. Here the diagram is given. For this figure we need to calculate the moment of inertia about x-axis and y-y axis. So the question is to find I-axis and IYY. Now, when we are seeing such a question of moment of inertia, we should see that if the given figure is symmetric or not. Here, the given figure is unsymmetric, that is, it is not symmetric about x or even y. So, for this unsymmetrical figure, we need to find out where is there its x-axis and y-axis, because once we know the x and y-axis at that intersection, we are going to get the centroid. So this problem will start with the location of centroid. So let us get started. Solution. Now first I'll say that since the location of centroid with respect to x-axis is given by the location of centroid with respect to x-axis, that is y bar, is equal to a1y1 plus a2y2 plus a3y3 upon a1 plus a2 plus a3. This I will keep it as equation number 1. Now after that I'll write down, therefore location of centroid with respect to y-axis is given by x bar is equal to a1x1 plus a2x2 plus a3x3 upon a1 plus a2 plus a3. So this will be the second equation. Now to calculate x bar and y bar, we need to divide this figure. So I will divide this into 3 rectangles, that is, here I'll say that this would be rectangle number 1 for us, rectangle 1, this would be second rectangle, and here we have third rectangle. So 3 different rectangles, and now we need to find the values of 3 different areas. So for rectangle number 1, the area is 2 into 14. That is 28 square centimeter. Area 2 is, now for the second rectangle, the width is from 24, I have to subtract 2 and 2 from both the sides. So 24 minus 4, that is 20. So 20 is the width here, 20 into 2 is the depth. This is 40 square centimeter. Area 3 is, now the width is 2 and the height is, it is 8 centimeter. So this will be 6. So here we have 2 into 8, so that is 16 square centimeter. So now after finding area, we can write down the x1 values. x1 will be the location of y-axis for the first rectangle, which is here. So this distance from the origin up till this y-axis, this is x1, and it is clear that it will be half of 2. So 2 and 2 get cancelled out. So x1 is 1 centimeter. Next, x2 is the y-axis for rectangle second, and its distance from here, that will be 2 plus half of 20, so it is 2 plus half of 20, so that gives us 12 centimeter, and x3 is equal to, it is 2 plus 20 plus half of 2, 23 centimeter. Now after getting x1, x2, x3 values, next I'll calculate the y values. So therefore y1 will be the location of x-axis for first rectangle, that will be at half of 14. So this distance is y1. y2 will be, the second rectangle is starting after 12 mm distance, so 12 plus, now its x-axis will be here, that is at half of 2, so 12 plus half of 2, that is 13 centimeter, and y3 will be, for the third rectangle if we see, now its y-axis will be here, this is 6 plus 2, that is 8, so at half of 8, that will be 4 centimeters. So, and it is starting after 6 mm, so 6 plus half of 8, that is 10 centimeter. Now after finding these values, I can say that put all values in equation number 1 and 2 respectively. So first, starting with equation number 1, in that we have y bar, so I'll put all the values here. So therefore y bar is a1 into y1, area 1 is 28, y1 is 7, plus area 2 is 40, y2 is 13, plus area 3 is 16, and y3 is 10, divided by area 1 plus area 2 plus area 3. So therefore y bar value, it comes out to be 10.43 mm from bottom, because all the references we have taken, it is from bottom. Next, therefore y bar will be, if I want to calculate the distance from top, because that is also required in the problem, so since the total height is 14, so from 14 I will subtract 10.43, so therefore y bar comes out to be 3.57 mm from top. So here, after finding y bar, we can locate it onto the diagram. Now y bar is 10.43 mm from bottom. Here this is 7, so 10.43. So it will be somewhere here. So here we have y bar 10.43 mm from bottom, and from the top it is at 3.57 centimeter distance. This is centimeter. Now here we have located the x-axis for this given section. Now we have to locate the y-axis, and for that we have to put the values in equation 2. So in equation 2, we were having x bar, so I'll put all the values here. So therefore x bar is equal to a1 into x1. a1 was 28, x1 1 plus a2 into x2 was 12 plus a3 into x3 is 23 divided by area 1 plus area 2 plus area 3. So here I get x bar and my answer is 10.43 mm. Here it will be in terms of centimeter because it is given in terms of centimeter. So this one is 10.43 centimeter from LHS, that is left hand side. Now similarly, if I want to calculate it from right hand side, so therefore x bar will be from the total width 24, I will subtract the distance 10.43 and it is 13.57 centimeter from right hand side. So here we can locate it onto the diagram, the y-axis. This is the y-axis for the given section having distance 10.43 centimeter from left hand side, that is LHS, and 13.57 centimeter from right hand side. Now wherever the x and y axis they intersect, that will give us the centroid. Now once the centroid is known, we can easily calculate the moment of inertia about x and y axis. So let us get started. Next, therefore mi about x axis is given by Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. This I'll keep it as equation number 3. We'll go on finding these respective values. So therefore Ixx1 is equal to mi about horizontal centroidal axis for rectangle 1. Now therefore Ixx1 is equal to Ig1 plus area 1 into h1 square. This is by parallel axis theorem. Now when we are using the parallel axis theorem to calculate Ixx, then in that case, if we look at the x-axis for this complete section, then the x-axis is located at 10.43 centimeter from bottom, but the x-axis for the first rectangle, which is here axis 1 1, this is located at half of 14, that is 7 centimeter from bottom. So it means there is the distance between the two axes is there. Now when we have the difference between the two axes, then only we can use parallel axis theorem. So here I have written that. So therefore Ixx1 is Ig1 is BD cube by 12. It is the moment of inertia for rectangle 1 about its own axis, horizontal axis, plus area 1 is B into D into h1 square. Now therefore Ixx1 will be equal to, now B and D values for the rectangle number 1, B is 2 and D is 14, 2 into 14 cube by 12 plus area 1, that was 28. Now h1 is 10.43 minus 7, square. So from this I'll get the answer of Ixx1, and it comes out to be 786.75 centimeter raised to 4. This is Ixx1. Next, similarly, Ixx2 is mi about horizontal centroidal axis for rectangle 2. So therefore Ixx2 is Ig2 plus area 2 into h2 square. This is again by parallel axis theorem. Therefore Ixx2 will be, now Ig2, if we see in this, the moment of inertia for the second rectangle about its x-axis, that is axis 2. So rectangle 2 is having B as 20 and D is 10. So it is BD cube by 12 plus area 2 into h2 square. So B is 20 and D is 2 cube by 12 plus area is 40. h2 is the distance between the two axes, which is the distance between the second rectangle whose x-axis and the x-axis of the given section, which is 3.57. So here this distance between them, it is h2. So h2 will be, as it is clear, from the top the centroid is located at 3.57 mm distance and x-axis for rectangle 2 is at half of 2. So from 3.57 we will subtract half of 2 to get this distance. Half of 2, that is 1 square. Now therefore Ixx2, it comes out to be 119.01 centimeter raised to 4. Now after getting Ixx2, the next thing is Ixx3. So therefore Ixx3 is mi about horizontal centroidal axis for rectangle 3. So therefore Ixx3 is Ig3 plus area 3 into h3 square. This is by parallel axis theorem. So therefore Ixx3 is Ig3 is BD cube by 12 plus area is B into D into h3 square. So therefore Ixx3 will be B and D values for the third rectangle. The value of B, that is 2, and D is 8. 2 into 8 cube by 12 plus area is 16. h3 is the distance between the x-axis for rectangle 3, that is at 4 centimeter distance from top. It is here 4 centimeter distance from top, but the x-axis of the complete section is at 3.57 mm distance. So there is the distance between the two axes, and this distance is called as h3. So it is 4 minus 3.57. So here I get Ixx3, whose value is 88.29 centimeter raised to 4. After getting these three values, we can put them in equation number 3 to get Ixx. So therefore put Ixx1, Ixx2 and Ixx3 in equation number second, equation third. So therefore Ixx is Ixx1 786.75, Ixx2 119.01, Ixx3 88.29. So from this the answer of Ixx it comes out to be 994.05 centimeter is to 4. This is the first answer. Now similarly we'll calculate Iyy. So next, since Mi for complete section about vertical centroidal axis, that is given by Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. So this will be equation number 4. So now we need to find out these three values. So starting with Iyy1, therefore Iyy1 is Mi about vertical centroidal axis for rectangle 1. So therefore Iyy1 is equal to Ig1 plus area 1 into h1 square by parallel axis theorem. Now therefore Iyy1 will be equal to Ig1 is, since we are finding the moment of inertia about y-axis, so Ig1 is the moment of inertia of first rectangle about its y-axis, which is here. So it will be dB cube by 12 plus area is b into d, and here we have h1 square. So therefore Iyy1 will be equal to, now d and b values for the second rectangle, d is 2 and b is 20. So 2 into 20 cube by 12 plus this is area is 40. h1 is the distance between the y-axis for rectangle 1 and the y-axis for the complete section. For the complete section the y-axis is at 10.43 centimeter and the y-axis of rectangle 1, this is at 1 centimeter distance. So from 10.43 we need to subtract 1, that will give us the distance h1. So therefore 10.43 minus, I'll write it as half of 2, so that becomes 1 square. So from the calculation of this I'll get Iyy1. The answer is, for Iyy1, if we look into the figure, actually the value of d is 14 and b is 2. So here we have 14 d and b is 2. So here I'll write down it is 2.0, which is 2, and area is 28. So from this I'll get the value of Iyy1, and the answer comes out to be 2.5 into 10 raised to 3 mm raised to 4. Iyy1. Similarly, I'll calculate Iyy2, which is the Mi about vertical centroidal axis for rectangle second. So therefore Iyy2 will be equal to Ig2 plus area 2 into h2 square by parallel axis theorem. Now therefore Iyy2 is Ig2 dB cube by 12, area is b into d into h2 square. Now if we look into the figure, The second rectangle, it has B is 20 and D is 2. So 2 into 20 cube divided by 12 plus 40. Now what is H2? The y-axis for the complete section is at 10.43 mm distance, but the y-axis for rectangle 2 is at half of 24, that is 12 mm distance. So here is the y-axis for the complete section, which is at 12 centimeter. So 12 minus 10.43, this value is h2, the distance between the two axes, and that is why we are using parallel axis theorem here. So 12 minus 10.43 square. So from this I'll get Iyy2, and my answer is 1.43 into 10 raised to 3 mm raised to, it is centimeter raised to 4. Next, similarly, Iyy3 is the mi about vertical centroidal axis for rectangle 3. So therefore Iyy3 is Ig3 plus area 3 into h3 square by parallel axis theorem. So therefore Iyy3 is Ig3 is db cube by 12 plus area is b into 3 d into h3 square. So therefore Iyy3 is d and b values. From the diagram, d is 8 and b is 2. h3 is the distance between the y-axis. Now here if we see the y-axis for rectangle 3, it is passing at 1 centimeter from right hand side, whereas the y-axis for the complete section is 3.57 centimeter from right hand side. So there is the difference between the two y-axis, and this distance is h3. So it is 13.57 minus half of 2, that is 1. So Iyy3, the answer is 2.53 into 10 raised to 3 centimeter raised to 4. After getting all these values, we can put the answer in equation number 4 to get Iyy. So after this, here is equation number 4. So we'll put the values here. So therefore put Iyy1, Iyy second and Iyy third in equation number 4. So therefore Iyy will be, Iyy1 value we have found out, it was 2.5 into 10 raised to 3 plus Iyy2 1.43 into 10 raised to 3 plus Iyy3 2.53 into 10 raised to 3. So after adding up all the values, my answer of Iyy comes out to be 6.46 into 10 raised to 3 centimeter raised to 4. Now this is the second answer. Previously we have seen that in this problem they were asking us two questions to calculate the mi about x-axis and y-axis, that is ix and iyy. So we had calculated ix, the answer is 994.05 centimeter raised to 4. Then we have found out Iyy value 6.46 into 10 raised to 3 centimeter raised to 4, and once we have calculated both the values, we can say that the problem has been completed.